Hello world and welcome to my channel. I'm Bound to Be Coding. In this series of quick tutorials I show you a feature of my game and then I tell you how it's made. Today's feature is a load and save system using encrypted JSON dictionaries. It's time for another show and tell. Let's get started. Okay, so I've reached a point in my game where I need to start loading and saving some data. And in thinking about how I wanted to implement this solution, I decided that I wanted to save my data in JSON files and I wanted to encrypt them so that provides some level of security over being able to manipulate the game data that I don't want the players to necessarily manipulate. And so my solution that you're going to see here in this video, I'm using Godot 4.3 and I'm going to be coding in C# 12, which is .NET 8. And I'm going to be doing that as opposed to using GDScript. GDScript has its place. I know enough of GDScript to use it. And it's great. It's fine. It's a great scripting language. But I'm a C# developer by trade, so I am more comfortable and more knowledgeable of C# than I am GDScript. And there's a lot of tools in the C# language that I can use that are not available in GDScript. So I'm going to be using C#. I'm also going to be using the dictionary in C# as opposed to the Godot dictionary. C# dictionaries are more performant. There's a lot of features in the language that I can use. I can link query against those dictionaries. They're strongly typed as opposed to the Godot dictionary loose type setup. And they're just faster, designed to do what I'm trying to do here in this game. And so I'm going to be using the C# dictionaries. I'm also going to be using Microsoft's JSON library as opposed to Godot resources. So you can save your data in Godot resources and they work. That the resource file is fine, but if you've ever opened up one in an editor, a text editor, you realize that there's a lot of cruft in those resource files. And so it's a lot safer if you're going to store data. In my opinion, it's a lot safer to just store data as opposed to storing your data in resource files, which can contain code. And if the resource files contain code, then and you're loading resources into memory, if you pick up that code from somebody else or from some other means other than just generating the code yourself, then that code could contain malicious methods that could, do damage. And so I decided early on that I would use JSON files to save and load my static and instance data, just because it's just data. It's just string data, and no chance that it's going to be malicious at all. And I'm also basically encrypting it so that I can have a little bit more protection over that data. Now I am using Godot's de-serialize. That class is really cool. It's got a lot of helper methods in it that are just very convenient for Godot and Godot games. And so I'm going to use de-serialize as opposed to system.io, just as a matter of convenience. Both work well, but I'm going to use de-serialize. And then of course I'm going to use system security cryptography as opposed to Godot crypto. Only because I'm in C#, I'm in .NET 8, it has the library for cryptography, and why not? I'll just go ahead and use it. Another reason is I really haven't used Godot's crypto library before. I'm sure it's fine. I'm really indifferent as far as, which one do I use. It's just more of a convenience thing, but I'm sure Godot's crypto works just fine as well. So that's my tech stack. What I'm going to be doing here in this short tutorial is showing you how to set up a load save system using these tools. Let's get started into the code. All right, so here we are in my game, A Struggle to Survive, and I am in a region that has been loaded, and I want to go to another region. So each region is, it has its tile map, it has its flora and fauna and objects that I've created and just different things, NPCs and whatnot. And when I leave this region, I want to go to another region. And so leaving the region, I want to save it in the state that it's in when I left. And when I get to the new region, if the region hasn't been created yet, in other words, I haven't visited that region yet, then it's going to generate that new region. If I have visited the region before, it's going to load that region data as opposed to creating it from scratch. And so the load save system is handling all of what I just described, and it's doing so very, very performantly. I must say, I'm very surprised at how fast this is working for me. So here I am in this region, and I'm just going to bide my time for a few minutes so that I can qualify to go to the next region. Explain that later in a later video. So there I went from let's see, I went from region 6.2 to region 5.2, and here I am. I'm in the new region, and all the data was all of the region was generated because I've not been here before, and you can see how fast that was loading. Now when I go back to the next region or the previous region, then I've got to save this region just like I did the first one, and I've got to load back in, as opposed to creating it from scratch, load back in that previous region. And so you can see that's pretty fast. I'll show you the numbers as far as how fast it was, and also the number of objects and how big the tile map was that I loaded. But it's very performant. And so that's basically what this video is about. The data gets saved as JSON, it gets saved as encrypted JSON, and it gets loaded, decrypted, deserialized back into the objects that are used in the tile map and in the world. So let's take a look at how I did this in code. Okay, so I'm in my code. I'm looking at my method save region data. And so this kind of, I'm not going to get into, creating the dictionaries and where do you put them and how do you store them. I basically store mine in a singleton. So I have a singleton called database, ASTS database actually. It's aliased as database here in this class. And the purpose of that singleton, so it is a singleton. In fact, it's the very first singleton at the top of my singleton list in Godot. And it holds all the dictionaries. It is, in effect, my database. All my dictionaries are my database. And so I have them stored there. And this method, basically, I use this method to save those dictionaries out of that singleton out to files. Each dictionary is saved to a separate file. And what you're seeing here is the sum of what it takes to do it here, and I'm going to show you some extension methods and how to do the encryption and how to deal with the JSON Vector2I object type that the JSON doesn't understand. Okay, so we're going to cover all that in this quick video. So my save region, I'm getting my paths and my file names, and when I get down here, I'm looking at my database, and for each one of the dictionaries, I've got an extension method that I'm using to save out that data. Okay, so I'm going to control click on the extension method here, and here's the extension method for saving the dictionary to an encrypted binary file. So I want to make sure I get everything in here so you can see it. So there it is. And after doing some checks to make sure that my input is good on this method, I create a JSON serializer converter so that I can handle the Vector2I. So if you don't know it, the JSON class, and this is true of Newtonsoft's JSON, this is true of Microsoft's JSON, they don't understand all of the different types that are out in the world. And so they only understand basic types like strings and ints and date and things like that. So in order for the JSON to understand or know what this type key is, in my case, I think 6 of my dictionaries are using a Vector2I as the key. JSON knows nothing about a Vector2I. It doesn't know what it is. So in order to handle the serializing and the deserializing, I am going to create a converter, or I created a converter, so that it knows that that Vector2I comprised of an X and a Y integer coordinate, it'll know how to serialize that, save it, and deserialize it back to an object. And by the way, if you've had trouble remembering, what is serialize versus deserialize, and how can I remember that? Very easy. S, serialize. S, string. So to serialize something is to take an object and convert it to a string. To deserialize is to take a string representation of that object and deserialize it back to an object. Okay, so S and S, you can remember. Serialize means I'm doing something with string, serializing the string, and deserializing, I'm taking that string and deserializing it back into an object. So I hope that helps somebody. So we've got the converter, and we're basically serializing the object. In this case, it's a dictionary. And once we get the serialized version of that dictionary, we're going to pass it to encrypt string to bytes, AES, which is the method that's going to encrypt the data. And then we're going to write that out to a file. Okay, so this is the save to dictionary encrypt. And this is the actual encryption method that is called encrypt string data to bytes. And it's going to return a byte array that can be written, encrypted byte array that can be written out to a file. All right, so I'll let you look at that, and I'll show you real quick how we handle the dictionary converter for the Vector2I converter for the JSON data. Okay, so I've created two classes here. This one here is the JSON converter itself. This inherits from JSON converter, and it is working with a type dictionary, Vector2I, with an object type value, whatever that value happens to be, whatever the type of the value being stored in the dictionary. What JSON can't handle is this Vector2I key. It doesn't understand what Vector2I is. So what this is doing is we are tapping into the JSON converter class, system text JSON, the JSON converter class, and we are overriding two methods. We're overriding the read, and we're overriding the write of that class. Okay, so I'm not going to get into it trying to explain all of this. It's pretty self-explanatory. I do have some notes in here, but I do want to draw your attention to one thing in a second. But I'll just scroll down, let you grab that method there, and here's the write down at the bottom. Pretty small amount of code here, but I do want to draw your attention to one thing. In my implementation of dictionaries, I typically store my key as a property in my value because it's helpful sometimes to be able to take the value in the dictionary and figure out what the key was from the value. And so I do that. You don't have to do that. If you're not doing something like that, if you're not storing your key as a property in the value in the dictionary, then you can pretty much get rid of all of that. Once I have the vector, I can assign the key of the dictionary to that value. Excuse me, I need to correct myself here. That's what you want to take out. You don't need that. All right, I'm only doing this. I am reflecting over the property called ID in my value object type, so that I can write out the vector that I've been able to deconstruct from the saved data using this converter. Okay, so you don't need this, but you do need everything else if you're not doing that. And then the write is the write method of that is down here. Pretty easy. Okay. All right. Now we're going to take a look at how we implement this is using a factory pattern. And this is the factory right here. So you create a class for your Vector2I dictionary converter factory. That's going to inherit from JSON converter factory. This is how we're going to implement it. And we're going to check, make sure we can convert it. And then we're going to do the converter. We're going to create the converter itself based on the type. And in this case, it's a Vector2I. Okay. You could do the same thing with a Vector2 or a Vector3 or really any Godot type that you need to store in JSON and have JSON serialize it and deserialize it. You can set up a custom factory and converter for that type, and you'll be good to go. Okay, it's once you know, it looks really easy, but it took a little bit to figure this part out because, like I said, JSON doesn't understand what a Vector2I is. All right, so that's what I'm doing here in the save region data. I've got my dictionaries. They're in my singleton database, and I'm getting my paths for my saved files. I save each one of my dictionaries to a different file, and using an extension method off the dictionary itself, I'm able to pass in what I need to pass in to handle the information. So let's see, what have I covered? I have covered the save dictionary to encryption and the encryption string data. The reason I'm a little muddle-headed right now is because I'm still a little frustrated. The software that I used to create this video about an hour ago, I got through the whole video and I looked over at the software, which I'm using OBS right now, and I had set up 2 scenes in OBS to handle my PowerPoint presentation, which was what you saw at the beginning of this video, and then a separate screen for the game and the code. I spent all this time developing this video, and I get it all done, and I go back and I watch it, and I find out that I forgot to switch scenes. And so what you're looking at here with the code and the game, yeah, that was all blank, all black, nothing, void. All you could see, you couldn't see anything. All you could hear was my voice. Oh, that was so frustrating. So now I have to redo this video. So I'm a little muddle-headed on, did I cover this in this video, or was it in the last video, or whatever? So anyway, this is our encryption methods. How we're dealing with. Oh, excuse me. This one here. This is our encryption method. So let me take a look at something, and I'll be right back. All right. So let me go back. I want to look at the next method that I have. So I have my save region data, and this is how I'm accomplishing that. And between region, save, and load, I reset my dictionaries that are in my database. I have a couple of helper dictionaries, or excuse me, some variable data that also needs to be cleaned up. Reset my dictionaries, and then I move down into loading the region data. Now, this looks very similar, doesn't it, to my save. The difference is that I've got another extension method for loading the dictionary data. And so for each one of my dictionaries, I'm going to call a method to load that dictionary. Let's take a look at that. So here's another extension. So here's the first set up here. Right, I'm sorry for scrolling so much. Right here, and the encryption. And now we're going to get into the loading. Again, just checking some values to make sure that I have the values that I need. You're going to set up a key and an initialization vector somewhere else in your code, and you're going to pull that in. That's the way I did it as parameters in this method. And then I'm going to do the reverse of what we did with the JSON and encrypting. We're going to load the encrypted data, and then we're going to convert that, decrypt it, and convert it back to JSON. And so that's what this method does. It calls the decrypt, which is this code here. You can take a look at that. And I'm not really going to spend any time explaining this. It's pretty self-explanatory. But I do want to show you that I'm using the JSON serializer again to load the Vector2I keyed dictionary. So we have 6 calls to that. And I want to show you also, so we have, this is the one I was referring to. So in my JSON factory, I've got, or it's, my file, my JSON factory file where I keep my JSON data, or my JSON methods, excuse me. I've got a load Vector2I key dictionary. So what I'm doing here is I'm basically saying, okay, I need my data from the file. So I'm going to call my load dictionary from encrypted binary file, which is going to decrypt it, convert it back to JSON, and give it back to me. And then I'm going to load that JSON data back into my tilemap dictionary. Now that I have turned it back into a dictionary object that I can use, I'm going to put it in my load Vector2I key dictionary. Now, because again, JSON doesn't understand what the Vector2I type is, I'm going to use that JSON serializer and that converter, okay, to deserialize my JSON data and return it back. And then once I do that, I'm good. Everything works well. Now, I have a separate method for the one dictionary. I have 6 references, so I have 6 dictionaries with the Vector2I key, and I have one dictionary with an int key. Since JSON understands what an int is, I don't have to create a converter. I can just simply do this, get my create a dictionary type using the deserializer of this dictionary with an int key and a, in this case, water zone object type, pass in the data from the decrypt, and I'm good. And that's it. I don't have to do anything else. So you can use this same pattern for Vector 2, Vector 3, really, again, any type that is in Godot that JSON does not understand, you can use this methodology that I'm showing you here to handle it and to load and save. Now, how fast is this? Well, we saw at the start of the video, it's pretty fast. There's a lot going on here. If I jump back over to my game and just oops. If I jump back over to my, sorry. Get up here. Okay, that region took longer because we have a region that has forest and plains. So about half of this map is forest, and these forest objects, these tree objects, there's quite a bit going on with the trees. So they have a lot of properties, storing a lot of information. It takes longer. Plus the sprites are bigger than the smaller plains, grasses, and things like that. And that all factors in to how long it takes to load and save. But even so, this was pretty fast. If we take a look down here, see if I can find it. Okay, here we go. So the region, the size of the region is a tile map of 65,536, 65536 tiles, all right, with 17,788 objects. In this case, this is going to be the flora objects, the trees and the bushes and things like that. Now, we were able to save that previous region in 87 milliseconds, okay? And that's pretty fast, isn't it? I mean, I think it is. And so let's take a look at back here. Let's I have a 5-minute delay on the user moving to another, or the player moving to another region, 5 game minutes, I mean. So I'm going to go back. Now you saw there in that example, we saved that previous region and we loaded this region. So this region had saved files. The other region, we saved the files. And so let's take a quick look at that, and you'll see that the previous region, it was saved in 37 milliseconds, and then the region that was loaded in 288 milliseconds. These are milliseconds, not seconds. This is really, really fast. And so if I bide my time and I jump back up here, now notice. So when I came previously, the region didn't exist, so I had to create it. And that's what took the bulk of the time creating the region. Okay, but once the region's created and I save, and then I go to the next region, I come back, well, the region files exist, so it loads it. And now we can take another quick look, and we can see that we have a region that was saved in 36 milliseconds. That is the previous region that I just left. And the region that we moved into, which was created and then saved previously, loaded in 108. Is that right? No, 100. Yeah, 108. My eyes are not what they used to be. I'm getting old. 108 milliseconds. So this is really, really fast. Okay, so I'm really happy with it. The load save system is working. It's really fast, and I'm able to save that data out to a file. And in fact, let me pause here, and I'm going to jump over to the file system, and I'm going to show you what those files look like. Okay, so I took a quick snapshot of the file system, and you can see that I have my my individual files for the zones, or excuse me, for the regions that I saved and loaded. And you can see that I believe A is the tile map, and you know it's 1,354 kbytes. And then I believe D is my flora, and it's 823 kbytes. These are relatively small. These are tiny files, but yet they contain encrypted data that work and secure my save game data so that I can have somewhat control over it. Okay. So there you have it, a loading and saving system that allows you to save your game data as JSON files that are encrypted, so they're secure, and it's performant. It handles the data well, and it's fast, and I hope you've gotten something from this video today. If you have, please give me a thumbs up and like. If you have any comments, please leave the comments down below. And if you'd like to follow me in this channel as I work on my game, A Struggle to Survive, a 2D survival game set in the 1800s, feel free to subscribe. And thanks for watching, and until next time, I'm bound to be coding.